Okay, students, let's continue from last time we talked about the introduction of vectors. Today I'm going to talk about vector in the coordinate plane. Alright, we're going to consider vector in two-dimensional space and three-dimensional space. For two-dimensional, you can think of xy plane. You only have two variables to consider. Okay, and in three-dimensional, it's going to be 3D, so it's going to have x, y, and z plane. Okay, so let's take a look at the dimension 2 first. So in any point in the plane, xy plane, I mean, for example, in this here, we have the point O, point R, point P, point Q. Alright. In any point, we can construct a vector, from the origin, which is the point O, to the point R, the point P, and the point Q, respectively. And we're gonna call them as vector OR, OP, and OQ. Alright, like in this figure 8. Okay, so the way you construct a vector, you just you have the tail from O to the height to the point R. That's a vector, right? And to the point P and to the point Q. Alright, and then next we're gonna represent each vector by the coordinate. The way we write the coordinate x and y, right? It's the same way we represent a vector in two-dimensional space, right? The set of all vector space in the plane is denoted by r square, or sometime you might have seen r cross r. Okay, which this guy represents the set of x and y. The set of order pair x and y, where x and y belong to the set of R. Okay, so we're going to represent each vector by using the coordinate, the order pair, I mean. Alright, here's what I just said. It's going to be written in here. Okay, every point in the plane can be represented by the vector, and it's called position vector of the point P, Q, R respectively. And the way you write the position vector is going to be this guy. So it's the vector OP with the vector notation on the top of OP, and then you write the order pair x1 and y1. And remember, x1 and y1 is just from the point P. Point P is x1 and y1. And in this lecture, we use the notation of point bracket. But if you study in some book, the way they represent vector, they use round bracket. So you have to be careful about how you use notation. But I mean, as long as you understand, you can use either round bracket or point bracket. It doesn't matter. All right. Okay. The number x1 and y1. Remember, x1 and y1 it's just a real number. We call them component of the vector OP. Okay, of the vector OP. Or sometimes we just use the short notation for vector OP, just P. But I would recommend you to always use OP. To get rid of the confusing. Alright, so let's take a look at this example. Sketch the position vector for A, vector I, -3 and 2, and vector B, 0 and -2. Okay. Right, so I'm going to draw it. let's just draw it. Okay. Alright, so I'm gonna draw them in the same XY plane. Alright, so we got -3, 1, 2, and 3, and 2, 1, 2. This is the vector I. Okay, this is the vector A. This is the point -3 and 2. Okay, and then we have 0, -2, which is down here. Let me change the color. I think this is the vector B. Okay, is 0, -2. This is how you sketch the position vector on XY plane. This is X, this is Y. Alright, nothing easy yet, nothing difficult yet. Okay, so then we look at three-dimensional space. We just generalize from the two-dimensional space. Okay, we have another coordinate, which is the coordinate Z or Z. Alright, so and the same concept, any point on the XY Z plane, you can write down the vector, in here. So, well, pretty much the same set of all vector on in the three-dimensional space is denoted by R square and not square, sorry, R cube, and R cube is just R times R times R, which is the set of X and Y and Z, where X, Y, and Z belong to real number set, the set of real number. Okay, so the position vector of the point P can be written as the vector of all P, and then you write it as x1, y1, and z1. Okay, and the same thing, x1, y1, and z1 is a core component of the vector OP. Okay, alright, and then now you can sketch the position vector, but this time it might not be easy to draw because you have to do it three-dimensional, right? So okay, let me try the best I can. So you have to draw X, Y, and Z plane here. Okay, and then you try -3, right? So it's gonna be in the back here. -3, maybe it's in here. I don't know. Should be here. And then X and Y and Z is 2. Okay, so here and here is 2. So you're gonna have something like this. Okay, I don't know how can I draw it. Yeah, but I think it should be something like this. Okay, let me revise it a little bit. It's not easy for me to draw. Let me think about it. Shoop. Okay, say this is 1, 2, and 3. Alright, and here is 1 and 2, and this is 1 and 2. It's here, and then you move. This is the projection X and Y and Z, and then you have to, I think you have to move down here a little bit. This is the vector A. okay, vector A. Okay, and then you have vector B 0, and then -2, -2 down is you have to go back here 2 unit 1 and 2, and then 3 for Z. So you have it here on the YZ plane. This is vector B. Okay. All right. Okay, this is just the way you will the vector, visualize it. Next, let's take a look at the vector with the initial point, not at the origin. So sometimes you have to consider in general, not just the coordinate vector, the position vector, but you might need to consider the general vector like vector PQ, vector PR, for example, like that. So let's take a look at how we find the vector if we are given point P and point Q, and we want to find the vector PQ or QP. Then this is the way you find it. So perhaps you have the point P right here. This is the point P, then this is the point Q in two-dimensional space. And if you want to find the vector PQ, the way you do is you use the concept is just like you do Q minus P. Okay, it's look like that. So you make you set up like this. You use the point Q, and then you subtract the P from Q. Okay, so here is what you get. It's gonna be x2 minus x1 and y2 minus y1. Okay, P minus Q. The same concept for the three-dimensional here. Okay, three-dimensional, you use the same concept. P minus Q, look like that. You want to find the coordinate for the vector PQ, so you have to do Q minus P. Okay. All right, let's take a look at these. Given the point P and point Q, P is -2, 3, and Q is 4, 5. Find the vector A and B in two-dimensional space corresponding to PQ and QP. Okay, easy one, right? So if you want to find PQ, remember you have to do Q minus P. Okay, so it's going to be the vector 4 minus -2. 4 is from Q, -2 is from P, and then you do 5 minus 3. 5 from P, Q, and 3 is from P. Okay, and then you just compute it. So you get 6 and then 2. That's the vector you want. Vector 2, 6, 2. All right. Next one, I want to find QP. QP. So you do P minus Q. So it's gonna be -2 minus 4, and then 3 minus 5. Okay, so you get -6 and -2. So you can see PQ is the negative of QP and vice versa, right? It's they are co-opposite vector to each other, right? PQ and QP have the same gradient if have the same slope or gradient if you draw it on the plane, but the direction are opposite to each other. Okay. All right. Pretty much the same. Given the point P and point Q, find the vector I and vector B in three-dimensional space that correspond to PQ and QP. So A is it's just PQ, right? So you do q minus p, so you get 4 from q minus negative 2 from p, and then you do 5 from q minus 3 from p, and then negative 2 minus 4. All right, and then compute it. So A is a vector of that can be represented by this coordinate 6, 2, and negative 6. All right, and for B, vector B is QP, right? So then the answer should be the negative of vector I. So negative 2 minus 4, 3 negative 5 minus 5, 4 minus negative 2. Okay, so you get negative 6, negative 2, and 6. Okay, all right, so hopefully you understand it. It's not that complicated, right? If you have seen it before, that would be great, because now you can go you can move on quickly. All right, so now let's consider something else that that's involved in the vector. So given we have two vector A and B, for example, here in two-dimensional space, if you want to add a vector, you just add them with the same coordinate. So the coordinate x, you add them, y, you add them. So in this case, you have a1 and b1, add them up, and the result should be in the first coordinate, right? Just on the other hand, a2 and b2, you add them up and you put it in the second coordinate. That's for y, right? Okay, that's the way you add the vector. Okay, maybe I just put the way you subtract here as well. Use the same thing, same concept. Put it in the right. So if vector A minus vector B, you're gonna get A1 minus B1, right? That's as you expect. A2 minus B2 here. Okay, but we cannot multiply vector to each other. That doesn't make sense. Okay, we don't have it in the vector. We don't have division as well, so you can only consider addition and subtraction. Okay, and another thing that you can do is you multiply it by scalar. You can just multiply by scalar, but you never be able to multiply by vector and vector. Okay, but there will be another thing that we can do. We're gonna call it dot product and cross product. Okay, but that will come up later. Let's finish it off this slide. Scalar multiplication. Well, suppose you have k, which is just a constant in the real number. You multiply k by, you do k times vector A. The resulting is you multiply k to each coordinate A1 and A2. Okay, it's just like a distribution. You have to distribute k to each coordinate, all of them. All right. Equality. If vector A and vector B are the same, then each coordinate, okay, have to be the same. So in this case, A1 must be B1 and A2 must be B2. And for the zero vector, can be represented by coordinate 0, 0, which is just the origin, right? Okay. Now let's compute this quickly. We have A and B. A is 1, 4, B is negative 6, 3. Then you want to find A plus B, A minus B, 2A plus 3B. Okay. Right. Let's do A first. So for A plus B, it just, so you do 1 plus negative 6, and then 4 plus 3. Okay, and then you get -5 and 7. That is the resulting factor. Okay, next b. Okay, b, a minus b. So 1 minus -6, 4 minus 3. So we get 7 and 1. Alright. What else do we need to consider? C, 2a plus 3b. So first you do 2a. 2a is 2 times 1, 4. Okay, and plus 3b, b is -6, 3. So we get 2 and 8. And this one is -18 and 9. You add them up. You get 2 minus -18, you get -16, and 8 minus 9, you get 17. That is for C. Okay. All right. Just the same direction of 2-dimensional. Despite we generalize it to 3-dimensional, you get the same thing, same procedure. If you want to add them, if you want to do the scale multiplication, equalization should be the same way, and then the zero factor. Alright, but I also want to add subtraction here. The subtraction is the same way as well. So you have a1 minus b1, a2 minus b2, and a3 minus b3 here. Okay. Alright, and if you want to, well, there is no example here, right? But you know, if you want to do addition, it should be easy. Subtraction is easy. Multiplication, you know, everything should be easy. So easy enough for you to understand. All right. So I think I should stop here for this video clip, and then the next video clip will be about dot product. Okay. So good luck for the studying, and thank you for watching. Bye bye.